much to attend. Question 14. Use Pascal's triangle to expand the following. So a x plus y to the power 6. Now Pascal's triangle is a triangle of this nature, a triangle of coefficients. Excuse. So it's a triangle of coefficients that are created in that manner, where you get to add the ones on top. So 1 plus 1 gives us a 2, and then the pivot ones will be 1s. And then 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So the second number that appeared here is always the power. So our x plus 6 plus y to the power 6, we calculate using these coefficients. The only thing you need to know is that we use the Pascal's triangle to just give us the coefficients and not the variable with the powers. So the issue of the variable with powers, you borrow from the binomial theorem, where the powers of x reduces as the powers of y increases. So we have x plus 6 plus 6 plus 6 multiplied by x power 5y plus 15 multiplied by x power 4 y squared plus 20 multiplied by x power 3 y3 plus 15 x power 2 y4 plus 6 x y5 plus y6. That's how you get that coefficient there, that expansion there, and nothing is new. You run throughout up to h using the same triangles. And the highest power I've seen here is 6. So powers like 5, 4, 4, 6, 5, all those have already been tackled, because when they say power 5, you get this line, power 4, you get this line, power 3, you get this line. Question 15. Evaluate the following expressions. A 6 choose 4. So we read this as 6 choose 4, coming from the definition of n choose r, where we get n factorial, divide by r factorial, and then get n minus r factorial. Keeping in mind that n factorial is defined as n minus 1, n minus 2 factorial, or you keep going until you reach 0 factorial, meaning you can end somewhere. If you choose to end, for as long as you put a factorial, everything will be correct. So coming to our question, we have 6 factorial over 4 factorial, and then 6 minus 4 factorial, giving us 6 by 5 by 4 factorial. I've chosen to end at 4 factorial there because I have another 4 factorial down. So it won't make sense for me to write 4 factorial on top as 4 times 3 times 2 times 1 and come down to divide the 4 factorial again. I expand it 4 times 3 times 2 times 1 as if I have enough time. So I won't do that. We'll just come and cancel this factorial here and get 6 by 5 over 2, where the 2 reduces 6 to 3. So the solution is 15. The next thing here will be C, which is a sum of 7, 3 plus 8, 4. Now, there are so many theorems surrounding binomial. You choose your own way, and the easiest for me is to simplify each of these guys in a manner that I know that it should be 4 minus 3. 4 minus 3 factorial, and then come back and add 4 factorial, 8 minus 4 factorial. So what I have is 7 by 6 by 5 by 4 factorial, because down here I have 7 minus 3, which is 4 factorial, to help me cancel that. And this 3 factorial will take away a 6. And then I have to add again, there is 8 by 7 by 6 by 5 by 4 factorial. Now, because there's no space, I won't write the 4 factorial down. I'll just write 1, which is 4 by 3 by 2. So that here, the 4 and 2 will help me take away the 8. The 3 will reduce the 6 to 2. So we have 2 numbers there. We have 35 plus 70, giving us 105. So you could use theorems if there are theorems that you know that will help you get the solution 105. Chongo.
Sir, I just want to verify why you reduce 6 using 3 factorial. Is 3 factorial the same as 3? Because I know that 3 factorial is 3 by 2 by 1.
So 3 factorial is 3 by 2 by 1. Very correct. But what is this number? This number is 6, is it?
Yes, sir.
So that's why it took away the 6 on top.
Thank you.
All right. Okay, so questions like F, they've been answered in C here. Because on F, that is 5 factorial over 3 factorial plus 7 factorial over 5 factorial. So there's nothing much to do there apart from, so E, when is it F? 5 factorial over 3 factorial plus 7 factorial over 5 factorial. Which is not a big deal because 5 can be written in this way.
Mr. Keith, I have a question.
Okay.
The way you have expressed that 3 factorial is same as 6. Then why didn't 6 cancelled with 6? Why did you cancel 3? You know, there are 3 into 3, 1, and then 3 factorial into 6, 2.
Not the, this was expanded as 4 times 3 times 2. So it's no longer factorial, it's just a 3. That's why it went to 6 to make it 2. This was 3 factorial here. It cancelled directly the 6 because 3 factorial is 6 also. That's how we said 3 factorial in 6 to have 1 and not the other side. This one we evaluated.
All right, thanks.
Okay. So 7 factorial here, we can also be written as this by 5 factorial, since we have a 5 factorial down. Notice what makes us stop on top there, that is because of what we have in the denominator. We are avoiding a repetition. You could go as far as, if you wanted, you could say 7 factorial over 5 factorial is the same as 7 by 6 by 5 by 4 by 3 by 2 by 1. Come down. What is 5 factorial? It is 5 by 4 by 3 by 2 by 1. And then you start cancelling. 5 in 5, 4 in 4, 3 in 3, 2 in 2, 1 in 1. So to avoid that thing, it's the reason why we just end the factorial there and then come down and say, okay, this and this will go. 5 times 4 is 20 plus this and this will go. 7 times 6 is 42. And then you add the 2. So 42, that one giving us 62. So what you normally do is that if we answer such a variety on one question, the next thing to mention is question 16.
So I have a question.
Please ask.
So what if there's no number in the denominator that you can cancel?
You have to evaluate everything. For example, if they ask you to find 9 factorial, there's no number down that you can cancel, is it? You have to find 9 by 8, by 7, by 6, by 5, by 4, by 3, by 2, by 1, by 0 factorial. But remember that 0 factorial is 1. So you should not have everything cancelled. But worry not, there will always be a number down. Okay.
Okay.
All right. So given the integers r, n such that 0 is less or equal to r, which is less or equal to n, prove that n r minus 1 plus n r is equal to n plus 1 r. And the other piece, so let's start with this one. We want to prove that these two are equal. Now you guys must not forget that we said nr is defined as n factorial, r factorial, n minus r factorial. And that if we have n factorial, we could go as far as n minus 1 and choose to end there. Or
So also it's on 15 number question 15K. I have a bit explanation.
okay, since I've already started 16, let's first finish this part.
All right.
So after knowing that n factorial is equal to n minus 1 factorial, it's just a guidance that you can move from the actual factorial to some number that you want if you want to use them for something. So it will be true that n minus 1 factorial can divide n factorial. Okay, so we'll reduce everything by one step. We'll reduce everything by one step. N factorial over r minus 1 factorial n minus r plus 1 factorial plus n factorial over r factorial n minus r factorial, giving us n plus 1 factorial over r factorial n plus 1 minus r factorial. So what we did here is we we subtracted n minus r minus 1. When you expand the brackets, you get n minus r plus 1. So don't be lost at that stage. There's nothing there. Then we pick the left-hand side. That's how we prove in mathematics. We can't move with both sides at the same time. So you pick the left-hand side and show that you're able to arrive at the right-hand side using the left-hand side. It means that they're equal. So our left-hand side, if you look at the way it is, it's a fraction, so it requires a common denominator. Now, what we have is r factorial, which can be reduced as r minus 1 factorial. This is to show us that the common denominator between r factorial and r minus 1 factorial is r factorial, which can be written in the form r minus 1 factorial. And then between n minus r and n minus r plus 1, you'd also notice that which one there is a common denominator? N minus r plus 1 factorial can be written as n minus r plus 1 multiplied by n minus r plus 1 minus 1 factorial, because we're able to subtract the 1 from the actual number and n there. So which will give us n minus r plus 1 multiplied by n minus r factorial. James. James, your hand is up. Okay, so this means that the common denominator between n minus r plus 1 and n minus r is just n minus r plus 1 written as a product of this, just to help us see properly. Then now we divide this denominator here into the denominator down here. What we are dividing is r minus 1 factorial divided by n minus r plus 1 n minus r factorial over r minus 1 factorial n minus r plus 1 factorial. So you notice immediately that this part takes away this part. The second thing that you notice is that this has been defined coming from this, which is down here. So one thing we remain with here is r, so to multiply the n factorial on top there, plus we divide again r minus 1 factorial n minus r plus 1 n minus r factorial by r factorial n minus r factorial. So this and this will cancel directly. Then r factorial here, this r factorial has been defined as r minus 1 factorial, which is this one here. So what we remain with on top will be multiplied by n factorial, which is n minus r plus 1, like that. So that becomes a common denominator, and then the up thing there, something is common on top. N factorial is appearing twice, so we can factor it out and remain with r plus n minus r plus 1 divided by, this is just r factorial, so it will be written as r factorial. This guy here is just n minus r plus 1 factorial. Yes. Okay. Then on the numerator there, what we have is this r and this r will subtract. So we just remain with n plus 1 multiplied by n factorial over r factorial n minus r plus 1 factorial. But this thing we have here, n plus 1 factorial, is not different from n plus 1 multiplied by n plus 1 minus 1 factorial, which is n plus 1 multiplied by n factorial, which is what we have here. So it can be written as n plus 1 factorial divided by r factorial n plus 1 minus r factorial. Just arrange this, they are already there, but this is the same as n plus 1, choose r, which is the right hand side. So that's how we do the thing there.
Excuse me, sir.
Right, excuse.
Yeah, on the from down on the third step, where is n factorial goes?
We have it in this form, is it?
Yes.
And we are saying this form is exactly the same as this.
Okay, okay, all right. I get it now.
All right.
So,
Hello.
so there is no another way you can use to prove to come to n plus 1 over n plus 1 plus r. There is no another way.
In mathematics, it's very hard to say there's no another way. The only response I can give is that this is the way I find to be safe.
Okay, but also I've come across the binomial properties like this one. I can see that r minus 1 is a difference from r. So I can just get r and add the n plus 1 plus r. Is it a good idea?
When they say proof, they normally wish to have it standing without theorems in it.
Okay, sir.
So this is a theorem, so it must be proved on its own without bringing another theorem. If you do bring another theorem, you must prove those theorems before you use them in another theorem.
Okay, sir.
All right. Then, so don't worry, I haven't forgotten the guy who has to go back to K. We'll get there. Let's just we also have NR to be the same as N minus R. So this one, since I have proved the longer one, you guys should enjoy the proof of this. Is it okay that you can enjoy this?
Yes, sir.
Thank you. And then, so don't forget that this theorem is telling you that this is equal to that. Now let's go back and make a comment of question 15K. Question 15K. The question is 6 choose 0, 1 over 3 power 6 plus 6 1 over 3 1 over 3 power 5 multiplied by 2 over 3 plus 6 choose 2 1 over 3 power 4 2 over 3 squared. So you keep going until the last number, which is 6 to 6. I'm sure you have seen what to do now. 2 over 3 to 6. Let's go back to the first question. When we had x plus y, the numbers kept going down, except that there we use the Pascal's triangle to get those coefficients. But from the theorem, they are calculated in this same way: 6 to 0, 6 to 1, 6 to 2, all the way up 6 to 6, if you use the binomial theorem. Okay. Binomial theorem, no, that one, we did the theorem in classes before we went home. So when you have such a thing, this is the same as having A to be 1 over 3 plus B 2 over 3 to the power 6. And then you're just using binomial to do the simplifications there. So that does not mean that you cannot do it. So I've made a comment, so you're able to do that. If you want, you can add the inside here. You get 3 over 3 to the power 6. This is 1 power 6, which is just 1. So imagine if you did,
Thank you, sir.
if you didn't know what to do here, how you would waste your time calculating all those coefficients and only to end up with a 1 as the solution. And then you say the exam was about. Okay. So we can safely say this drill sheet is done.
It's done, sir.
Is there any question?
I thought like that's when we were starting.
If there are 18 questions and they have gone as far as question 16, and question 17 and 18 are the applications of question 16, then it means that you are done, because
Story sheet what?
Story sheet 5.
Story sheet
So
5.
did you do question 5?
Did we do question 5?
Eh,
I mean, we did question 5 when we are living on campus. This question came in Story sheet. Find a set of values of k for which the equation has no real roots. I mean, this question came in Story sheet 3. Was that Story sheet 3 or Story sheet 2? And it was answered on campus.
Answer.
Hello.
You have the recording for from question 1 up to 4.
From question 1 up to 4.
Yes.
At the time we did question 1, we didn't record, and that's the day we did question 2 as well. But I think from 3 it was shared last time we had the class. How was it shared? No, there was an interruption, so it was not shared. I mean that there's no recording.
What about for question 4?
No, even question 4, that's one that we attempted last week. But question 4, the only one that I remember which has a recording is question 4K, which I sent in the group, if you remember.
Oh, okay, thanks.
The one for the modulus. But we have serious issues from question 1 up to Okay, so we're doing Zoom. Only 4 minutes are remaining. So we can log out and quickly come back. We start to sheet 6.
Sir,
Hello.
yeah.
So where are you going to post the notes?
The link for the video posted in the group. I don't understand what you mean by the notes.
Yeah,
Give me
but
question 17, sir.
Okay, let's log out and come back. We start to sheet 6.
Question 17, sir. You can go through it.
Okay, can you make a comment when you come back?
All right.
Yeah, now scribbling nowadays, Zoom shows who is scribbling, so it's not a good idea to scribble.